Okay, we're going to be looking at the vertex and the axis of symmetry of quadratic equations. So a quadratic function always starts with f of x. Sometimes it might have like a y there, but most of the time it's going to have f of x or g of x, and then it have ax squared plus bx plus c, kind of what we've been working with so far in factoring and completing the square and all that. The quadratic equation is the function, but it's set equal to 0. And that's really what we've been working with all through this chapter when we factored an equation or completed the square or used quadratic formula, any of those. So we always had to have it equal to 0. So everything has to be on one side. So all of it has to be on one side. So if it's not, you need to put everything on one side, and it needs to be in this form in order to factor or anything like that, or complete the square. The quadratic part of it is the ax squared. That means if I would graph our equation, it's going to make a parabola. It could go up or it could go down. It will always make a U shape. So the quadratic, that's the ax squared part. That's why the squared makes it, parabola makes it like a U shape. If it was linear, then our graph would either just be a straight line this way, or it could be this way, or it could be horizontal. So linear just means it's going to be a straight line. So that's the difference between quadratic and linear. Okay, so let's say we have this equation. F of x equals 3x squared minus 5x plus 10. And so everything's on one side. Our quadratic term is the 3x squared. The linear term is the negative 5x, and the constant is 10. Alright, let's try another one here. So we want to find out what is the quadratic term, what is the linear term, and what is the constant term, just like we did up above in the green there. But first of all, it's not in the form that we're used to seeing, ax squared plus bx plus c, so we have to get it into that form. So we have x plus 4 squared minus 20. Well, x plus 4 squared means x plus 4 times x plus 4. So you have to FOIL that, and if you would FOIL x plus 4 times x plus 4, you get x squared plus 8x plus 16. Then you also have the minus 20 down here, or up there. So now you have to combine your like terms, so I have to combine the 16 and the negative 20. So my final answer would be x squared plus 8x minus 4. So now I do have it in quadratic form. So my quadratic is x squared. My linear term is 8x. And my constant is negative 4. Alright, next we have the axis of symmetry. Oops, sorry about that. So our axis of symmetry. All parabolas have this, and what it does, it cuts the graph or the parabola in half. So if I have a graph like this, and here's my parabola, and let's say this point right here is 3. So if I would draw a line straight through that, you can see it cuts the parabola right in half. Half of it goes to the right, and half of it goes up to the left. So the axis of symmetry is the line that goes straight down through the x-axis and cuts that parabola in half. So that's the point there. So the axis of symmetry on this one would be x equals 3. And on the blue one, there's a parabola, and it cuts it half at x equals negative 2. So half of it goes down to the left, half goes down to the right. So what it does, it just cuts it right in half. And here the axis of symmetry would be x equals negative 2. And next is our vertex, and all parabolas also have this. This is where the parabola and the axis of symmetry intersect. So if I have a graph, and I have a parabola, the green is my axis of symmetry, because that cuts it right in half. This point right here in the black, right there, that is my vertex. So it's where my parabola and the axis of symmetry intersect. So that is my vertex right there in the X. If I had it over here, and my axis of symmetry was this green line, which means it cuts it right in half, the parabola, then my vertex would be this blue point right down. So it's the very bottom of the graph, or the parabola, which is that point, or it could be the very top of it before it starts turning over. So those are the vertexes, the bottom and the top there. Alright, now next is your zeros, and we've already been working with that too in this chapter, so this is nothing really new to you. But if I have a graph, and I have a parabola, your zeros are your x-coordinates. It's where the graph intersects the x-axis. So it'd be this point right here in green, and this point right there. So let's say that point is 2 for the x-coordinate and 0, because we're on the x-axis, and let's say this one is 5, 0. So that means if I would put 2 in my quadratic function, or my quadratic equation, my answer would come out to be 0, which makes sense because since I'm on the x-axis, my y-coordinate is 0. Same thing if I put 5 in the equation. If I put 5 in the equation, solve it, I would get 0 for an answer, which also, like I said, makes sense because my y-coordinate is 0. So those are the zeros. Those are kind of like our solutions there. And right here I have 2 solutions. If I had an equation or a graph that was like this, touch it there. So it's only touching in one spot right there. That would be one root or one solution. Or I could even have a parabola that has no solutions because it's not touching the x-axis at all. Alright, so let's try a problem here. So we have a function f of x equals x minus 4 squared minus 1. And we want to find the vertex and the axis of symmetry here. So we're going to graph this, but we're going to find out where those points are. So we want to see what the graph looks like and find the vertex and the axis of symmetry. So first of all, we have to get it in the form of ax squared plus bx plus c. So once again, I have x minus 4 squared, which means x minus 4 times x minus 4. And if I would FOIL that, I'd get x squared minus 8x plus 16. I also have this minus 1 up here, so I have to put that in there. So I'll combine my like terms, which is this and that, so I'd have x squared minus 8x plus 15. Alright, so first we're going to find the axis of symmetry. And to do that, all we do is take this equation, negative b over 2 times a. So in our equation, a equals 1, b equals negative 8, and c equals 15. Alright, so we have negative b, so we have negative 8, or the opposite of negative 8, over 2 times 1. So we have 8 over 2, which would be 4. So that is our axis of symmetry. So if I would graph that, and I'm going to go to the next page to graph that. So if I would graph that, I go to 4. Let's just say that is 4. That's my axis of symmetry. So that is my axis of symmetry right there. It's going to go through the x-axis right at 4. So that means half my graph is going to go up to the right, and half is going to go to the left. Alright, so now next we're going to have to find the vertex. And the vertex, we're going to take our axis of symmetry, which is 4, and we're going to put it into our equation. If you remember, our equation was x squared minus 8x plus 15. So I take the 4, our axis of symmetry, put it in our equation. So I have 4 squared minus 8 times 4 plus 15. So I'd have 16 minus 32 plus 15. So that's negative 16 plus 15, which is negative 1. So our vertex then now is at 4, because that's what I put in for x. I put in 4 for x. and my y-coordinate now is -1. So this is my vertex. So I go over to 4 and down to -1, put a point there, and that's my vertex. So the blue point is my vertex. So the axis of symmetry was the green line, my vertex is the blue point. Alright, now next we have to find out what the graph looks like, or how's this going to go up. So we have to find more points. We only have 1 point right now. So we have to find some other points so we can connect our graph to make that parabola. So we have to make a table of values to find that out. So I'm going to go to the next page here and make a table. My x terms and what my y terms are from that. I'm going to go back to my previous slide here. What you're going to do then is you're going to take 2 points, x coordinates to the right. So I'm going to use, since this was 4, I'm also going to take 5 and 6. So I'm going to take 5 and 6. And I'm also going to take 2 points to the left of it, 3 and 2. And I'm going to put those in my table. Alright, so I got my points. Now I'm going to take each one of those points separately and put them in for my equation. And so I don't run out of time, I'm just going to do number 5 first, and then I'll just give you the answer, the y-coordinates of 6, 3, and 2. So I put 5 in there, square it, minus 8 times 5, plus 15. So I have 25 minus 40 plus 15, and that all equals 0 there. So I had, because 25 minus 40 is -15, plus 15, and that's 0. So that's 0. So I'd do the same thing with 6. I'd take 6 and I'd square it, minus 8 times 6, plus 15. So I have 36 minus 48 plus 15. And if I'd solve that, I would get 3. So it'd be 3. Then I'd do the same thing with my x-coordinate of 3. Put that in my equation. I'd get 0 out. And if I put 2 in my equation and solve it, then I'd get 3 out. Now, of course, you can see that there's a pattern, 0, 3, 0, 3, because I went 2 points over, 2 points to the right and 2 points to the left. And since my graph is symmetrical, you're going to have the exact same y-coordinates there. Because that's the line of symmetry makes that the same on both sides. Alright, so now I have the coordinates 5, 0, 6, 3, 3, 0, 2, 3. So I'm going to go back to my previous graph here. I'll plot those points. I'll do those in black. So I had 5, 0 to be right on the line. And I had 6, 3, so that'd be about right there. And my other coordinate was 3, 0, which is right on the equation, or excuse me, right on the line. And my other one was 2, 3, so that'd be about right there. Connect those points the best you can, up and up. And then there would be your graph here. So there's my parabola. So I found 5 points there. Found the axis of symmetry first. Found the vertex. Once I had the vertex, then I'd take 2 points to the right, 2 points to the left, x-coordinates, put those in my equation to find my y-coordinates. Now, of course, it could be going down, so it just depends on what your equation is. Mine just happens to be going up because the a-coordinate, the a value of my equation was positive, so it's going to be going up. So if your a-coordinate there for x squared was negative, then your graph would be pointing down. So hopefully this will help you, and take your time and go back over it if you need to. And if you have any questions, please ask. So I guess that's it. Bye.